Hey everyone, this is Q, and we were back to another day of a daily Leetcode problem. We're going to first start with my warm-up on Typeracer to get my fingers warmed up, and then we'll check out the problem. Once again, I'm just going to use a practice one, and then we'll go from there. Okay, not too bad. Let's go ahead and go now to the Leetcode problem of the day. Number 1930, a unique length 3 palindromic subsequences. Given a string, return the number of unique palindromes of length 3 that are a subsequence of S. Note that even if there are multiple ways to obtain the same subsequence, it is still only counted once. A palindrome is a string that reads the same forwards and backwards. A subsequence of a string is a new string generated from the original string with some characters. Can be none deleted without changing the relative order of the remaining characters. Okay. So we're only looking for things that have a subsequence size of 3. I wonder if we can use some kind of like two-pointer method. So say if we had 2 pointers, A and A, we know everything between them is going to be a palindrome because it'll have one thing in between, right? And in this case, it's 3. As long as everything within the boundaries are unique. But then how do we decide there's a second one that's outside of it? Like, okay, so this one has ABA, right? Let's use that as an example. So if I was going to do it the way I was saying, 2 pointers, I would be going left and right and finding 2 things that are the same. So in this case, B and B. Everything between B and B, 4 subsequences, except 2 letters are identical. So it's actually 3. Probably use a temporary frequency map to compensate that out. Unfortunately, this method might not work. It might be Oven squared. I mean, okay, so you're only looking for a character that is of the same. But worst case scenario, nothing works because there's no identical letter. And then the worst case scenario would be Oven squared because it has to check left to right, left to right, left to right for every single one. At 10 to the 5, I think that we need something like a linear solution. So kind of like one pass. Or not really necessarily one pass, but big O has to be Vin. And in that case, I wonder if there's a different way of doing it besides this. Let me think. Okay, here we go. Hold on. What if we used one pass? So it's going to be a two-pass solution. The first pass to store the last index of each character in a vector. And so then on the second pass, we would already know what the last index is, and we just need to do the frequency. Or count up all the copies. So you only take one. We'd have an unordered set. Hmm. I feel like the time complexity would still be really bad. I feel like we also need how many unique letters are between letters, but I don't know how we would do that. I say that I should say characters. Hmm. Yeah, so I was right though. So the only ones that matter are the first and the last of each character. So this. Okay, let's write it down. So first 0, and then 2, 4. Okay. Last of B. 5. 2. is the last one, right? So that is 6. We know that there has to be more than one. They have a frequency map. I don't know. Okay, so we know that we can do B and A. Right? If we know the first one and the last one, we know that all we need to do is check from 0 to 5. Put each character in maybe a set. And so we'd have 3 unique values, which means 3 palindromes. Try that. I feel like I might be way off base here, but okay. Anything that becomes over... Well, I'll just iterate through the frequency. Oh wait, while I'm doing this, maybe we should have... Okay, so we're going to have the character is going to be associated with maybe the frequency. And the first and the last of its values, right? Because I feel like we don't need to actually... If we're just going through this anyway, and we're going to increase the first value by 1, then we might as well use, I don't know, a tuple. Right? And then we can have, the tuple is going to be, say, count. Would it let me do that? But then we can't use first. We have to use that weird thing. It's like get. One second. I'm just gonna look up the tuple stuff. It's got, yeah, it's like get, and then 0 through 1, 2. Okay. Trying to remember how to store a tuple. Shoot, I can't remember how to specifically use tuples. Okay, let's just do pair pair. It's easier this way. Okay, so then we can do something like this stuff first. This is my count. And then we can just say if frequency SI first is greater than 1. First we're going to go if SI equals 1. Then we want to set the first. We're going to go frequency SI first dot first. This is first. It's going to equal the index of I. And then if it's greater than this, we are going to update it for every single one that's greater. So there's only one index for first, and then every single one thereafter is going to be updated. Okay. I did this wrong. Oh yeah, hold on. Frequency, put in the character. The first pair dot first is just an int, right? And then the first of the, sorry, this is second. Second dot second. Yeah, we go. Okay. So this should give me all the information for what I'm trying to do. Then all we need to do is go through the values and count the number of unique characters, right? Okay. So going through the map is going to give us all the characters, and we only want to check it if f dot first equals 1. Okay, so if there's only one character in here, like C, it'll just go away. And then anything else, we just need the unique set of characters. Okay, so we're going through the indexes for S. And then we're going to say result equals unique. Right? And then we just return result. I don't feel like this is because this is going to be O of 26. Hold on. F dot second Dot second should be an int. Oh wait. F dot second is this. Oh wait, they want... Okay. Oh. Hold on. Okay, I outputted 5. Go from here to this index. Expected 4. Oh, hold on. We have the first, the last of each character. What is it printing? Then it goes to the next one. Oh, hold on. Wait, it still didn't work right. This is the character. This is the count. I don't want the count. I want the... Oh wait, I did this backwards. Let's just make sure that's working correctly. Four to 6 for A. 4, 5, 6. Okay. B is 0 to 5. All right. First off, this is equals to. I wonder if this is being caught up in there. F dot second dot first. F dot first is the character. F dot second dot first is the count. The count C should be 1, which is skipping. What is causing this? Hold on. We're getting 2 and 3. So A should be 1 value. Oh, that's what I'm doing wrong. I don't think this is gonna, I don't know if this is gonna be efficient though. I mean, the concept should work, but I don't know. Well, it works. Kind of slow though. I wonder if I can make this a little better though. This is O of 26. I mean, it's not bad. I think this is still O of 26 times n. I guess I'm okay with the solution. Let's go ahead and just look at the other solutions before we go. See what other people did. C++, leftmost and rightmost indices. Bit set. They're at most 26 by 26 times. Wow. Function. I would not have come up with this solution. That is crazy. Two solution, prefix and suffix. Okay, anyway, I solved the problem. I'm happy with it. This was January 3rd. The problem was 1930 unique length 3 palindrome subsequence. Thank you for watching my vlog of dailies. Have a good day, everybody. Later.